Let's do some practice with scientific notation and some per capita. So first we're just going to do some scientific notation problems, and in this one we're multiplying. So 3.2 times 1.5 gives us 4.8. And recall, when you multiply same base, you add the exponents. So negative 5 plus 3 gives us an exponent of negative 2. Scientific notation because the first number is between 1 and 10. Number 2, again we're multiplying. 4.5 times 8.3 gives us 37.35. Negative 2 plus 4 gives us a positive 2. Now you'll notice the first number is not between 1 and 10, it's larger. A larger number than 10 yields a positive exponent. So if I move this one place, that means my exponent goes up by 1, so it's positive. So 3.735 times 10 to the third is my final answer. Number 3, now I'm dividing. I do recommend rewriting 2.57 times 10 to the 6th. Whatever comes first goes on top. So I divide these numbers, and a rounded answer is 1.98. It is between 1 and 10, so we're golden there. And now that I'm dividing, I subtract. 6 minus 8 is negative 2. And there's my scientific notation answer. Now let's play with some per capita. The NOAA, which is the National Oceanic Atmospheric Administration, reports that there are 17.8 million feet of Atlantic coastline in the state of North Carolina. If the population of North Carolina is approximately 9.5 million, find the number of feet of coastline per capita. Okay, so now we're looking at number of feet of coastline per capita. I like to think about it in terms of words first before I go to my actual mathematics. So what's the coastline? There are 17.8 million feet. And there are 9.5 million people. Now, because they're both in million, those can cancel out. And I'm really just doing the problem 17.8 divided by 9.5. That makes it a little bit easier. And when I do that, I get 1.87 feet of coastline per person in North Carolina. Now, obviously, they don't all live on the coast, because if they did, they'd have 1.87 feet. That's not very much room. Number 2, the NOAA also says there's just over 6 million feet of Pacific coastline in the state of Oregon. If the population of Oregon is approximately 3.8 million people, find the number of feet of coastline per capita in Oregon. Okay, so now again we're doing number of feet of coastline per capita. So in this case we've got 6 million feet of coastline over the 3.8 million people. Again, the millions cancel out. 6 divided by 3.8, there is 1.58 feet of coastline per person in Oregon. And how do those compare? So in North Carolina, we had 1.87 feet per person, and in Oregon, we had 1.58 feet per person. Well, you can see there's a difference, and there's a difference of 0.29 feet. So in North Carolina, each person has 0.29 feet more coastline than people in Oregon. So if your goal is to have more than 1.58 feet of coastline, you should, maybe go to North Carolina. But 1.87 is still not very much. Okay. All right, let's look at this table. We've got 5 states. We've got the number of school districts, K through 12 school districts in each state, and then the population. Recall or notice that the population is in millions, so we're talking like times 10 to the 6th for each one of these, right? Just a notion here. Now, we're going to do Indiana together, and then I'm going to have you go through and finish the table. But first it says school districts per capita. So school districts is what's going to go. So we want school districts per capita. So for Indiana, we've got 297 divided by 6.5 times 10 to the 6th. Now, you might need to put that in parentheses depending on your calculator. And depending on your calculator, it may spit it out in scientific or standard form. My calculator spits scientific. So it gives me 4.57 times 10 to the negative fifth. And this tells us how many school districts per person. Well, you would imagine that would be very small because there's more than, one person in a school district. So in standard form, I move my decimal 5 places to the left. So 1, 2, 3, 4, 5, right? That 4 is one of the decimal points, 0.57. So I want you to complete this table, Illinois, Kentucky, Michigan, and Ohio, finding the per capita for school district per capita in standard form and scientific notation. Then come back, check your answers. All right, you can see each one has an exponent of -5, and they just have different numbers. So because they all have a -5 for an exponent, right, those are all consistent, you can compare by using those first numbers of who's bigger, who's smaller. All right, so in working for number 2, we're going to scale up Indiana. So Indiana's per capita is 0.000457. Now to go per 10,000, we're going to multiply that number by 10,000. So if we take that per capita times 10,000, we get 0.0457. So that's per 10,000. So if you have 10,000 people, you're going to have approximately half of a school district, is what that's saying. Per 100,000. So if we do per 100,000, then we're going to take the number and we're going to multiply by 100,000. And that gives us 4.57. So you put 100,000 people in a room, and you're going to have about 4.5 school districts, is what this means. Per 1,000,000, you're going to multiply the per capita. All of these things over here, they're all, take the per capita, multiply by 1,000,000, and you're going to get 45.7. So if you put 1,000,000 people in a room, you would have approximately 45.7 school districts. Which one of these makes the most sense? This is my personal opinion, but I think B, the per 100,000. So if you were thinking per 100,000 people, we would have about 4.5 school districts. I'm going to round that just to 5 because it would round up. 4.5 would round to 5. So for every 100,000 people, Indiana has 5 school districts. That's what that means. And last, which state has the most school districts per capita and which has the least? Now, I'm going to, wrong button. Going back to this, and I mentioned earlier that you can just compare these numbers. If you compare, Illinois has the largest front number, so they have the most school districts per capita, and Kentucky has the smallest number, so they have the least. This only works because all of these exponents are the same. So they're easy to compare because they're all the same. If there'd be any difference, you'd have to go per 100,000 or per 10,000. Make them consistent. But right now they're all times 10 to the negative fifth, so they are consistent. So you can go ahead and make that comparison. So who has the most? Illinois. Who has the least? Kentucky. And that's playing with per capita.